All right, for homework number 32, we're going to start off with some pre-calc stuff. So this says determine the missing coordinates of the points on the graph. So I left my answers in here. Y is equal to arctangent x, and I've drawn a little bit of my unit circle here to help jog my memory. So let's go with the point on the far left here. So the x is, so this is y equals arctan of the x value, which is negative radical 3. Remember, for arctangent, your only possible solutions to this, we're answering the angle here, are between pi over 2 and negative pi over 2. So I'm looking for where the y over x is radical 3 over 1. So that's definitely pi over 3. But I need it to be negative, so I'm in the negative pi over 3 section of the quadrant, because tangent is negative in this quadrant and positive in quadrant 1. So that's where the negative pi over 3 came from. And then let's do the next point here. So now this time we're provided the y value. So negative pi over 6 is equal to arctan of x. And so we're supposed to figure out what the function value is. Another way to think of this is take the tangent of both sides. This is probably an easier way to think of it. Tangent of arctangent is x. And then you're just evaluating what's the tangent of negative pi over 6. So the answer is negative, and then the tangent of pi over 6 is 1 over radical 3, which I rationalized like we usually do into negative radical 3 over 3. And then the final point here, again, we are given a y value, pi over 4. We're setting that equal to arctangent of x. So to solve this, take the tangent of both sides. Tangent of pi over 4 equals tangent of arctangent, which is just cancels out, of x. Tangent of pi over 4 should be an easy one for us. Y over x is 1. So that's where the 1 came from. Evaluate the expression without using a calculator. So again, for arcsine and arctangent, remember the angles that you're allowed to use in your solutions are between pi over 2 and negative pi over 2. And we're not saying like 11 pi over 6. We're saying negative pi over 6. So, all right. So what's this one going to be? Arcsine of 0. What angle makes sine equal to 0? That's 0. Arctangent of radical 3 over 3. Remember, that's like 1 over radical 3. Unrationalized. So which angle makes tangent equal to 1 over radical 3? So the ordered pair at pi over 6 is radical 3 over 2, 1/2. So that would be y over x would be 1 over radical 3. So this solution is pi over 6. Evaluate each expression without using a calculator. So sine and arctangent do not cancel. Arctangent of a number is just equal to some angle theta. So we're trying to figure out what's sine theta. And we can figure out sine theta if we have a triangle to go off of. So example 3 was figuring out, we did this in our notes too. Let's set up a triangle. If theta equals arc tan of 3/4, then tangent of theta is equal to 3/4. So I can put theta wherever I want. And then opposite over adjacent is 3/4. The hypotenuse would be 5. And now I can turn around and say, I've got this triangle. The sine of theta is equal to opposite over hypotenuse, 3/5. Same thing for this one. So arc sine theta is equal to arc sine of 4/5. So again, we're just going to be evaluating secant of theta. We just need a triangle to go off of. You can take the sine of both sides to get rid of the arc sine or inverse sine. So sine of theta is 4/5. That is a different triangle than where I placed my theta before. That's opposite 4, hypotenuse 5. That makes the adjacent side 3. Now secant is the reciprocal of cosine. So if cosine was 3 over 5, this is going to be 5 over 3. All right, next problem. Write the expression in algebraic form, hint, sketch a right triangle as demonstrated, again in our notes. So same idea here. This is equal to secant of theta. And we can figure out secant of theta if we have a triangle. So we can say, okay, theta is equal to arc tan of 4x. Let's take the tangent of both sides. So tangent theta equals 4x. Technically, this is 4x over 1 to help you draw the triangle. So I always put theta in this little acute angle down here. Opposite of theta is 4x. Adjacent to theta is 1. Use Pythagorean theorem to get the hypotenuse. It's the square root of 1 squared plus 4 squared. 4x squared, excuse me. Okay, so now that we have our triangle set up, the secant of theta is the hypotenuse over the adjacent side. So that's the square root of 1 plus 16x squared over 1, and we'll just leave it at that. You are not allowed to, remember, you're not allowed to individually square root terms because you would have to do this addition first and then take the square root. You can't go against order of operations. Solve this equation for x. So again, I want to get rid of an arc sine. So I'm going to take the sine of both sides. So taking the sine, I'm trying to erase this. There we go. Taking the sine of arc sine just leaves you with 3x minus pi, and that would equal the sine of 1/2. Sine of 1/2 is not something we have without a calculator. Remember, we can do sine of like pi over 6, pi over 4, pi over 3, or anything around the unit circle. So to solve this for x, I would just say, okay, it's whatever sine of 1/2 is. I could use my calculator for that. Plus pi, divide the whole thing by 3. That solves for x. I'm just going to leave it like that, though. I don't need the decimal approximation. Okay, now on to calculus. Find the derivative of the function. So remember, you could draw a triangle except for number 43. When you have a number out in front, the triangle doesn't work. Or if it does work, it doesn't work easily. So I'm going to remind myself, what are the two derivative formulas I need? See how it's arcsine and arctan? I do have an arc cosine in here, which I guess I'll have to look that up. But yeah, so let's just write down the arcsine and arctan formulas. So the derivative of arcsine of u, it's equal to u prime over the square root of 1 minus u squared. And the derivative of arctan of u is equal to u prime over 1 plus u squared. I think it's worth your time and effort to memorize these because that makes the whole process a lot easier. We don't have to do the triangle thing every time. So just like we did in the last two examples in the notes, let's just use the formulas. And we need to on 43. All right, so if I'm going to do that, first I need to set up what is u. So u is x minus 1. What's u prime then? That's just 1, so that's not bad. There's a 2 out in front. So f prime of x will be 2 times, and then what do we get for our derivative of arcsine? So it's u prime, which is 1, over the square root of 1 minus u squared, x minus 1 squared. I'm not going to bother squaring that out. I'm just going to maybe put the 2 on top. So 2 over the square root of 1 minus, you could square out that quantity if you want and combine like terms, but I don't think that's necessary. So find the derivative. We found the derivative. What about 47? So the u is the e to the x. The u prime is e to the x. So f prime of x. So what's the derivative of arctangent of u? It's u prime over 1 plus u squared. Now you should get in the habit of e to the x squared is really just e to the 2x, because you're going to see that written like that for our problems on the AP test. You need to recognize that e to the 2x means e to the x squared. All right, what about this one? So u is going to be square root of x. What's du dx, or what's u prime? This is x to the 1/2. So it's 1/2 x to the negative 1/2, or let's just put a square root of x down there. All right, so f prime of x is equal to, this is arctan, so it's u prime, 1 over 2 radical x, over 1 plus u squared. Now x to the 1/2 squared. We're going to simplify all this. So 1 over 2 radical x. And then what's down here? This is really just 1 plus, that becomes x. It should be in parentheses, otherwise the math is not the same. So gets rid of my complex fraction. I just moved the denominator down here. Sine of arc cosine. So when I take the, now remember, this is like saying sine of theta, but I think I'm going to do a little bit of chain rule here. First, I'm going to take the derivative of the sine of something, and then I'm going to take the derivative of arc cosine of t. So what was our arc cosine formula? Of arc cosine of u. If I remember correctly, it was the same as arc sine. It just has a negative in front. So it's negative u prime over square root of 1 minus u squared. Let me just confirm that. We don't often have to use arc cosine. So let me just double check this here. Yeah, negative u prime. Okay, so that's not too bad. All right, so h prime of t is going to equal, what's the derivative of sine? Cosine of arc cosine of t times the derivative of arc cosine of t. So that's going to be, okay, so t is our u, right? We don't really like, u is our t, u prime du dt would be 1. So, okay, so this is going to be negative 1 over square root of 1 minus t squared. What about this? Cosine of arc cosine cancels out. So you have negative 1 times t over the square root of 1 minus t squared. All right, so I didn't use any triangles here. You could use the triangle thing, but I think the formulas for these two especially are pretty nice to use. Find any relative extrema of the function. So relative extrema, that means first derivative test, right? So we need to find f prime. Now this is just arc sine of x. So you can do the u thing if you want. U is x, u prime is 1. So the derivative of arc sine of x is going to be 1 over the square root of 1 minus x squared. And the derivative of 2x is minus 2. Now we're trying to find critical numbers, so let's combine some like terms here. So if I want this whole thing to be over the square root of 1 minus x squared, I can leave this 1. This minus 2 gets multiplied by the square root of 1 minus x squared. What are the critical numbers? Well, let's start with the denominator. When f prime x is undefined, we get x equals plus or minus 1. So we're going to plot those. And then when f prime x is equal to 0, that's when 1 minus 2 radical 1 minus x squared is equal to 0. Let's add the 2 radical 1 minus x squared over, divide by 2, square both sides. I'm going to add x squared over here and then do 1 minus 1/4, which is 3/4. Square root, x is plus or minus radical 3 over radical 4, which is 2. Okay, so we have all kinds of stuff to put on a number line. So let's see. It's bothering me that was not more horizontal. All right. So I'm testing into this f prime. And let's see. Radical 3 is like 1 point something. So when you divide it by 2, it will be, so the order of these numbers go negative 1, negative radical 3 over 2, positive radical 3 over 2, and then positive 1. And remember, arc sine's domain is anything between negative 1 and 1. So we can plug, we don't need anything on the outside of negative 1 or 1, but we do need to test these 3 intervals. So arc sine of x, the trig values that you can get are negative 1 to 1. All right, so let's plug in something between negative 1 and negative radical 3 over 2. So how about, let's see, how about negative radical 3.5 over 2? That ought to work, right? So what if I test that? So I get 1 minus 2 times the square root of 1 minus, now if I'm plugging this in and squaring it, I'm getting 3.5 over 2 over, now this is a square root down here. That's always positive. And this is positive as well, right? So this is like 1 minus 2 times, so let's see, this would be, oh, no, wait, now what have I done here? Oh, this should be over 4, sorry. When I square radical 3.5, I get 3.5. When I square the 2, I get 4. Okay, so 4 minus 0.5 over 4 is the square root of 1/2 over 4, square root of 1/8 over this positive. Let's see. So is this positive or negative? So square root of 1/8 is like 1 minus 2 times 1 over 2 radical 2. 1 minus 1 over radical 2, that's positive, right? Because 1 over radical 2 is 1 divided by 1 point something, so it's smaller than 1. That was a lot of work to get me to positive. Okay, let's plug in 0. That ought to be nicer. 1 minus 2 square root of 1 minus 0 over, this always positive, or 1 minus 0 again. That's definitely negative. 1 minus 2 over a positive. And then now here's a nice thing. I don't have to redo this work because I'm squaring this radical 3.5 over 2. So I'm going to get the same as I got when I plugged in negative radical 3.5 over 2. So that's positive. So F is going from increasing to decreasing to increasing. So there is a relative max at, oh, I haven't found the point yet. Hold on. Let's go ahead and find the relative extrema. So what is f of negative radical 3 over 2? So that's the arc sine of negative radical 3 over 2 minus 2 times negative radical 3 over 2. So what does that come out to? Arc sine of negative radical 3 over 2, that's negative pi over 3 plus, these 2's cancel, radical 3. Okay, so negative radical 3 over 2, and then I'm going to call it radical 3 minus pi over 3. That ordered pair is a relative max because f prime changed positive to negative. All right, and then what's f of radical 3 over 2? Positive version of that. That's the arc sine of positive radical 3 over 2 minus 2 times positive radical 3 over 2. So this is positive pi over 3 minus radical 3. So the ordered pair radical 3 over 2, pi over 3 minus radical 3, is a relative min because f prime changed from negative to positive. That was a lot of work. Okay. Last couple of problems. Here's a true or false. Because cosine of negative pi over 3 is 1/2, it follows that arc cosine of 1/2 is negative pi over 3. That is false. Because we went over this in our notes, remember arc cosine, the range for arc cosine can only be angles between 0 and pi. So the arc cosine of 1/2 is not negative pi over 3, it's pi over 3. Okay, what about this one? An airplane flies at an altitude of 5 miles toward a point directly over an observer. Here's a little picture. Write theta as a function of x. So we have opposite and adjacent. So I can begin by saying tangent of theta is equal to 5 over x. Now writing theta as a function of x means solve this for theta. So take the arc tangent of both sides, and theta equals the inverse tangent or arc tangent of 5 over x. So that's it for that part. Now part B says the speed of the plane is 400 miles per hour. Now find d theta dt when x is 10 and when x is 3. Now the speed of the plane is flying toward the observer, which means x is decreasing. So because x is decreasing, the distance from the plane, a point under the plane to the observer, dx dt is equal to negative 400 miles per hour. All right, so this feels like a no find u. So that's what we know. This is related rates. That's what we know. We want to find d theta dt when x equals 10, and then again when x equals 3. And what are we going to use? We're going to use our formula for theta. Theta equals, let's write this as arctan, so it looks more familiar, of 5 over x. All right, so we're going to take the derivative with respect to t of both sides. All right, so this just becomes d theta dt, not exciting. What's the derivative of this arctangent function? So off to the side here, I'm going to say, okay, u is 5 over x. U prime would be negative 5 over x squared. Okay, and then because we're taking derivatives with respect to x, but we're supposed to be going with respect to t, we will chain rule after that. All right, so this is going to become u prime, negative 5 over x squared, over 1 plus u squared, which is 25 over x squared. That derivative needs to get multiplied by dx dt for chain rule. Now let's plug in what we know. So d theta dt, when we evaluate at x equals 10, you could clear out the x squared, by the way, but I'm not. Well, no, I probably will, actually. So no, I'm not going to. Sorry, indecisive. Okay, so I'm not going to worry about simplifying. Let's just keep going. So this is negative 5 over 100 over 1 plus 25 over 100 times negative 400. Okay. And I'm not sure if I used a calculator on this or not. Actually, let me take a look at my key here. Did I use a calculator? If I used a calculator, I didn't have to go through all that work just now. Oh, no, I didn't. Okay. All right. Anyway, so let's see. So what does this come out to be? So for negative 400 times negative 5 over 100 is positive 5 times 4, so positive 20. Over, what's this down here? 125, 100 over 100 plus 25 over 100. So multiply that around. 20 times 100 is 2,000 over 125. Now, what's the label on that? It's d theta dt. So that's got to be radians per hour. We're increasing at that many radians per hour. You could get a decimal approximation for that if you want. What about d theta dt at x equals 3? That's going to be negative 5 over 9. Maybe I should, let's go ahead and multiply by x squared over x squared. Let's just see what that, so d theta dt, maybe that'll make life easier. That's negative 5 over x squared plus 25. That seems a lot easier. Right? Times negative 400 because dx dt is constant. All right, so let's do that. All right, so for this part, so when I plug in 3, I get negative 5 times 400 is the positive 2,000 again, over x squared plus 25, so 9 plus 25. So that's whatever 2,000 divided by 34 is. And again, I'll call it radians per hour. Part B, or 98, says repeat with an altitude of 3 miles and describe how altitude affects the rate of change. So in interest of time here, because I'm running out of it for my planning bell, let me go to my worked out problem here. So all I've done was change this to tangent theta equals 3 over x. So before we had 5 over x. So theta is now arctangent of 3 over x. So we still know that dx dt is negative 400. I did a slightly different u sub here so that when I do my formula, instead of negative 5 over x squared, it's negative 3 over x squared over 1 plus 9 over x squared. Let's get the x squareds out of there. That becomes negative 3 over x squared plus 9. And dx dt is negative 400. So, okay, I did find the decimal approximations here. So let's take a look at this. So when the altitude was 5, d theta dt went from 16 to 58 or 59 roughly. And then here it went from 11 to 67. So that lower altitude, even though the initial at when x was 10, even though that point that was further out was increasing faster when the altitude was 5, the overall rate at which d theta dt is changing is higher, right? Theta is changing faster when you have a lower altitude, which makes sense. Just think about a plane coming at you and you're moving your head to look up. It makes sense that if the plane is lower, you have to move your head faster to change that angle to be able to see it. I guess that's sort of, in my brain, that makes sense to me. All right. And then what was our, oh, that was our last problem. Sorry. So yeah, to save time, I just didn't want to rewrite all of that because it's essentially mathematically, it's all the same mechanics. But yeah, d theta dt has a faster change here from 67 to 11 compared to 59 to 16. All right, that finishes this video. Please come see me in office hours if you have questions on any of this stuff.